Hi, everybody. Even though we've been told not to read them, I have been reading a lot of YouTube comments about Windows, especially a lot of questions about Swift on Windows, when we're getting Arc out, and what it's like behind the scenes. And so I wanted to give a little preview of that. What you're about to watch is a little internal presentation I did about Windows. We cut it down a bit, but wanted to share some context on why we're doing this, some of the behind the scenes, and hopefully it's interesting.
So, the first and most high-level question was, why is Windows important, and why would we focus most of the company on it? First of all, it's 75% market share. Sorry, last week I said 85%. That was actually wrong. It's 75% market share, still a lot, and the majority of the market. Studios adoption, Studios is on hold for now, but we're going to get back to it at some point. And so for collaboration, if your entire team can't use Arc, you're not going to use collaborative features. And the last is, look, we have this vision of an internet computer. That's what drives a lot of what we're building with Arc. And part of that vision is that you should be able to access your internet computer from any device you're on. And Windows, of course, is the biggest one, the most relevant to us. And so it naturally is the next step.
Windows was always a priority because, again, if it's 75% market share and we're after really reinventing how people access the internet, it doesn't really behoove us to stay on Mac. It's just too small a pool. Honestly, we're about almost 4 years in. I did expect us to get to Windows sooner. It just turns out reimagining a browser takes some time, and reimagining how to build a cross-platform browser in a way that's iterative and memory safe takes time as well. And so we're here finally 4 years later working on this, and in some ways the perfect time to do it, based on where our technology or our growth, our product is at. But it's always been part of the plan and part of this internet computer vision.
A big question I got from several folks was like, what's the big deal with Swift on Windows? Why is it so interesting? If we think about cross-platform software, viable choices to build cross-platform apps are kind of slim. That's why we started with a fork of Electron when we first started this company, even though performance was awful. It's because, okay, how do you actually build cross-platform software? There's not a lot of choices. There's a lot of people have tried a bunch of stuff, React Native, Flutter, Xamarin, Qt, but they're all kind of janky in their own ways, And I think a good test for this is like Apple or Adobe would not use those. Or we would not use those technologies for a reason.
Yeah, I feel bad saying janky because there's a lot of, and I have a lot of friends who've put in a lot of effort into React Native, into Xamarin, into Flutter. And so they're incredible pieces of software, don't get me wrong. It's unbelievable what those teams have managed to accomplish. What I was trying to say here is that for a certain level of performance and craft, you're just going to hit walls with those. And so, for browsers or for Apple or for Adobe software, ordinarily using those levels of interaction is a little tough. And, you get into these little janky experiences. And so, no disrespect, it's an incredible piece of software, all of those.
They're also just not considered cool. And so people don't love using them, quite frankly, which matters. If you have a bunch of engineers who are building stuff, you don't want to be using a framework that's not that interesting. And so really every serious cross-platform application, like browsers, like Apple, they write everything in C++. That's really the only viable choice for a very performant, craftful application that is going to go really have a broad audience. But C++ is not ergonomic, and crucially, it has manual memory management. The genius thing about Swift is that they basically took number one and then just have the compiler put those calls in. And so, the first version of this, they just had in Xcode, they would just tell people when they forgot these calls. And then eventually they just had it automatically. And it took them decades to build this, where they just automatically handle memory management, but without the garbage collection pause. And so this is huge, actually. Ironically, it's called ARC, automatic reference counting. And it's decades of work from Apple where they have automatic memory management without these garbage collection pauses. And this is huge. This means you can have C++ level performance without any of the security issues and ergonomic issues of this manual memory management. And so Swift on Windows, and maybe eventually Android, provides a real viable alternative to C++ for the first time. And this is not a small thing, actually. This is a viable alternative for Apple, for Adobe, for Microsoft, for these big companies as well, who who would not consider using anything besides C++. It just doesn't make any sense to build it in C++ when it's so much slower and there's no memory safety. So this is a big deal in terms of we may see this actually being used in all of the big companies as we start to stabilize this.
Interestingly, this is a little bit strategically problematic because we're building a web browser. And so people investing in web technology and building cross-platform tools with stuff like Electron and websites is actually much preferable for us and better for us. Having said that, we're still going to open source all our work because, we're standing on the shoulders of giants. Our browser is built on Chromium. That's incredible amounts of work from thousands of people, and it's all open source. We're on Swift. That's all, a lot of it's open source. And so it behooves us to be humble and sort of give back all the work we're doing, because we wouldn't be here without all that work. And so we're going to open source this. The idea is all of it. There's actually, most of it is already open source. Like, a lot of the work we're doing are in open source repos like the Swift repo or the SourceKit repo. And so, a lot of the work we're already doing is public. We're not, arrogant enough to think people will jump on this immediately. That people have ways to build cross-platform apps and Windows apps that they really like. But a lot of the reasons we're making this choice, I think, will be the same reasons others will. And I've outlined those. It's memory safe, it's performant, it's ergonomic. People like writing UI in Swift. And so our hunch is the same reasons other people will be excited about, especially big companies as well, since they have a real viable cross-platform mechanism this way.
So what's involved in making that work? It seems like a lot of work. Like, how did we actually get here where we have a viable shot at making this into production in the next several months? So I drew this little graphic out. We're going to refer to this graphic throughout the presentation too. And so I thought a little visual representation would be helpful. At the bottom, there's the compiler and toolchain. Then there's sort of the foundation libraries. These are the ones that come from Swift. And then we have a bunch of Windows ones. And then this is the actual Arc application here with the base libraries. And then this is what's missing. Salim has been spending 6+ years getting this compiler and toolchain working since 2017. So we really cannot say enough about the incredible work he's done here.
Unbelievable, right? First of all, one human to be capable of this is wild. And then somebody to have the vision and foresight to be like, this is a project worth embarking on because there's no viable cross-platform toolkit outside C++. And Swift is the one that is going to, because Apple spent 15 years building it, or however long, I made that up. But this is the one that is going to take the cake. And so I'm going to literally sit down and invest in making it work on Windows. And it's taken 6 or 7 years, but he got it there. And he is also just one of the most unbelievable engineers I've worked with. It really does feel like he's 10 people in one. He's just so unbelievably productive and thoughtful, and he knows this whole stack top to bottom too, which is just wild. And so it's an honor really to work with him and, to build on top of the work he's done. It's incredible.
This is the rough map of what we're looking at, but we're getting there. We're almost there. And a lot of the stuff that's left, we feel like we can do in just a few months. Cool. And so, related to that was another question, which is how much time are we actually saving with Swift over C# or C++? I definitely think we're saving a lot of time over C++. Again, it's not easy to write and iterate in. Polling a few Windows folks, they mentioned probably 2 to 3 times faster in Swift. C#, it's unclear. It depends on how much code we share. And a lot of that we're going to figure out over the next 3 to 5 weeks as the Windows product pod kicks off. But I want to say, I don't think this is the right framing. Because of performance, memory safety, iteration speed, and code sharing, I just think C# and C++ are just not viable for us compared to the immense benefits we get from using Swift, especially as the code sharing grows. It's easy for me to say now that we've de-risked it and it works. Obviously, it was a different call 6 months ago and we had no idea if it would work and we would waste 6 months. But at this point, I don't even think it's worth considering these two heavily if we know Swift is going to work and it's how it's turning out to look, which is really, really cool, actually. It's looking really good. What does the Windows app currently look like? This is a very quick demo from Steve, interlude, where you can show off what it's been looking like recently.
Steve. Sweet. Yes. Hey, everyone. I am joining from Washington, where we have the best barbecue and that is because I make it myself. A little plug there for my own cooking. Cool. Everyone see my screen? Yes. Okay.
Yes.
Okay. So as for what Arc looks like today, this is a version of Archie, which I have out for review. It's kind of like meant to be a preview app. It's a version of Arc that actually, uses web, like Microsoft's WebView. It doesn't have Arc core, and it's kind of hopefully made to be like a little playground for people to play around with and get familiar with it. So this is what we have right now. We have kind of a little sidebar here, which hovers out. We have folders. I recently added a little button content with a flyout here for creating like new tabs and folders.
So, that prototype took him 2 days to build. So like that prototype is not a huge amount of work. It's the fact that it shows, hey, you can build UI applications in Swift on Windows, and they're stable and they work, and you can build them in this way that allows you to iterate quickly. Everybody just seeing that, I think, made it feel quite visceral. And then, Steve goes on to show some of the animations as well. I think folks seeing, oh, you can have these animations with easing, that are really expressive. I think just gets folks excited on the possibilities, because we have the product muscle to take that now to amazing. But if the building blocks weren't there, we wouldn't be able to do anything with it.
And I think one of the really exciting things that Hursh has talked a little bit about in our in this chat today is kind of what it looks and feels like to build WinUI in Swift. So if we switch here to my VS Code window here, this is the source code for that little view I have, the little flyout I just showed you. And it has this nice declarative Swift UI like syntax here where you can create a button with a flyout, and so when I click on that button, this UI shows. And so it has a really nice, a really ergonomic feel to it, which is really exciting. For folks who are familiar with WinUI, like the natural way to build things is very declarative with XAML. Well, they have very different. They have a XAML file, which is XML, and then they have their C#, C++. I think we actually kind of have a really nice marrying of the two, which is really cool.
One thing we're working on is how to make building features and UI on Windows really painless and feel really nice to use. And that's something, certainly the JavaScript ecosystem with React and some of these frameworks have really invested in. That's something that Apple is really invested in with Swift UI and building that out. And it just makes writing features way faster, much less of a chore than sort of how to typically do them in C++ and even in Swift and other languages. Windows has the same in C#. C# has its own sort of like templating mechanism. There's also a separate language called XAML that's XML based that you can write stuff in. And both of those are pretty good, but we wanted to give our shot at it here in Swift. Because Swift actually has a bunch of tools to build these kind of templating mechanisms because they built those to build Swift UI. And so we can use those same tools to build a really nice way to build UI in WinUI that'll allow us to iterate quickly. And so I think that's what seeing the syntax, people were like, ooh, this looks familiar and like fun to code in as opposed to a pain. And so that's what people were reacting to.
Yeah, and then the other thing too, so we also have another preview app that I'm going to show as well. And this is a very simple preview app. It's hopefully going to grow over time, but it's basically kind of designed just to show like animations. And I bet no one can see the animation based on this being over Zoom and over network, but it's just basically a very simple app that, just like animates the scale of a button when I hover over it. And but basically here is like just a very simple code here where you can just listen, know when your pointer goes over an element and you just kick off an animation. And you'll see like very natural, normal Swift things, lazy var, where you create your animation. So yeah, that's what we have so far.
Wild, Steve.
Yeah.
That's awesome.
Thank you.
And I want to call out that those preview apps and that declarative syntax was built by Steve in the last 3 or 4 days. So, a lot of the stuff is very quick to iterate in. It's not a lot of lift. So what are the biggest risks at this point? Now it's just timing. So we can definitely get Arc out in like 6 to 8 months. I think 5 to 6 months will be a push. And there are a bunch of things that could delay us that we'll have to be on top of. One, as I mentioned, rethinking our core architecture, that is a sort of like endless rabbit hole we can go down based on the learnings from iOS and macOS. And so we'll have to be wary about how much we like reinvent the wheel here, because again, that'll take time. This one scares us a little bit. WinUI is pretty janky and buggy at times. It's still not fully stable. This would have been a problem in C++ or C# either. This is not Swift specific.
We're learning more. We're learning a lot more as we're digging into it. Even this week we had a kickoff on the point that says rethinking our core architecture, and like, oh my God, is it a rabbit hole? Like, it could be easily 3 years of work. And so it's like a daily challenge to figure out, okay, how do we squeeze this into the next 5 to 6 months? And what do we need to de-risk? How do we sequence it? So, I continue to be wary about promising anything, because at any point something could show up that just completely derails our timeline. But 100 problems down and 100 more to go. And so that's kind of where we're at.
This was a question if people asked, what are designs and mocks coming for Windows? I'm sorry, Dustin, to put you on the spot if you have any idea on this.
Yeah, soon. So we're starting to dig into it. I've got my Windows machine set up, and we're already talking to the WinUI folks and have had those conversations. Going to start digging in to Figma on this side, because there's WinUI component libraries in Figma, so we can even just start standing up potentially what the Arc on Windows could look like before we start even writing the code, just to have quick Figma prototypes to start feeling that out. So yeah, excited to start doing this very, very soon.
Dustin, how's the barbecue in Vancouver?
Yeah, there were comments of like best barbecue in the US, and I think Vancouver's probably best barbecue across the world. So I respect how you are showing up in the States, but at a global level, y'all need to come up here and visit. So
cool, thank you, Dustin. So what will the schedule look like for product engineers jumping on Windows? And what's our ramp going to look like? This is a really good question. A number of people ask this. Q Sprint, which is August 14th through September, 12 to 16 product engineers, ideally doubling this. Our aim is to make it parallelizable enough to support that. How do we feel about perf on Windows? This is a pretty big question. This is a serious concern. I don't know if we have any sort of silver bullets here. Our perf is already middling, and Windows is all Intel CPUs and a wide variety of hardware. This is going to take us some time to get right. The mitigations we have, perf improvements we make now in shared code will affect Windows. So as we improve perf on the Mac app, a lot of the view layer ones may not, but the rest of them, like actual feature changes we do, Chromium, shared code, TCA, all of that will affect Windows. And then everyone will get a performance computer. They're like, there's Windows computers for $200. And so, you'll all get one. You'll be able to test what it's like there and sort of see how it goes. How are we approaching Arc on Windows from a product perspective? Like full feature parity? Is it just a few features? This is very much a Dustin question. Again, depends on the time to port features. We may change plans based on what we learn. But with iOS, we did do fewer features with more polish. And so there's a world where we do the same on Windows, but again, depends on what we want. But we do want eventually feature parity between Mac and Windows. So that's a friction we'll have to figure out. Does that mean we cut stuff on a Mac? Does that mean we put stuff on Windows later? How will Windows feel different from Arc on Mac? We're excited to make the best version of Arc because we can start from scratch. So a lot of the product stuff we'll figure out as we go. I think mobile is a great example of this. And that's it. Sorry, I had to burn through the last few.
Don't apologize. That was awesome, Hursh.
It's been a lot of our strategy so far is like, can we take very high risk bets, de-risk them, systematically. And because we're very good at product and engineering, like finding creative ways to de-risk them as we go. And go for the most elegant outcome, that checks a lot of boxes. And so, how we use Chromium was a first example of this. And then a second example of this is Windows, where, as Josh said, from a cost structure perspective, it's actually a huge gain because we don't need two separate teams. We can have one team that can flex. And that flexibility is actually really important because we can, Swarm people. There's certain people in the team that are very skilled at one particular thing, certain interactions. They can work across platforms. So that's a huge boon. And then from a technical perspective, all the sharing code, being able to not have these diverging products will be incredible as well. So it just felt like a really elegant solution that we're paying for with a lot of risk. And then we use the skills we have to lower risk, to just systematically lower risk over time and get there, basically.
I know we have 1 minute. I just wanted to end by saying, I think the feeling I hope everyone has after this presentation is there are a lot of questions that we have to answer. We have pretty good answers for most of them. We will figure it out. This company is very good at this. This is why we hired the class that started today and the ones before and after it. Like, the people we're attracting are incredible. And I also just want to call out, since everyone doesn't see it, our board of directors believes in this as much as we do. So I think at other companies, initiatives like this can be a little bit at odds with what the kind of business or leadership at the highest level wants. Here it's in direct alignment. Our kind of business-oriented board director loves this for the operational cost structure leverage we'll get at scale. Mike Krieger, CTO, we put a CTO on the board for this moment. He's as inspired by this as we are. So I just want to note for everyone, like, we're going to do this. We're going to figure it out. And it's not just us doing this project we think is neat. Everyone at the highest level believes that this is the right call for the company. It also, again, even happens to align with our big goal of the year, which is growth. And Windows is our biggest growth lever. So yeah, just want to end by shouting out everybody that Hursh mentioned that got us to this point. I know we're so far, but it's been a heroic, it's been a huge effort up to this point. Hursh, you as well. And I think, again, we all joined to do the work of our career. I think if and when we do this, people will ask what it was like to be at the browser company when we did this. So I'm so thrilled for this.